So hello everyone, so we are back here. So we are solving DSOP problem list. Okay, so yeah, let's go and let's search DSOP here. Okay, last 6 months. So we are done with the first missing positive, and yeah, it was quite a good question, and we'll have some. Okay, just give me a moment. Yeah, we are on the day 7 of the placement prep, guys. Okay, let's just. Okay, so it's day 8 and we are already done with first missing positive. Yes, so now okay, so now we will be going with get the maximum scores, guys. Yeah, or should I go with um, an easy question? Let's see. Yeah, I'll go with get the maximum score. Okay, okay, let's go with it, guys. Okay, I'll start the timer and let's see. So we have been provided with two sorted arrays nums1 and nums2. A valid path is defined as follows: choose array nums1 or nums2 to traverse from index 0. Traverse the current array from left to right. If you are reading any value that is present in nums1 and nums2, you are allowed to change your path to other way. Only one repeated value is considered as the valid path. The score is defined as the sum of unique values. Okay, let's try to break down this question. As usual, let's write observation and approach, then have constraints. Okay, so let's first try to understand. We have been provided with two arrays. Okay, then the next thing is I can choose any nums1 or nums2 to traverse from index 0. If you are reading any value that is present in num1 and num2, you are allowed to change your path to the other way. Okay, so I can start from any index 0 of nums1 and nums2, and if a value is present in both of one, I can change from this to another path. Okay, so the score is defined as the sum of the unique values in a valid path. Okay, sum of unique values in a valid path. So this is it, guys, and I have to return the maximum score that is possible. Okay, and what are the constraints? Talking about the constraints, the length of array size, if I can say, it is greater than 1 and less than power 5. Okay, okay, let's take an example here. So I can start from 2 or I can start from 4. Let's say I start from 2, then I can go from 2 to 4. I have the choice to continue it. I can either go from 2 4. Now I have a choice. Should I go and change the path from 4 6? Okay, okay. And one more thing which have been provided is that both arrays are sorted. Okay, I can change the path, right? I can either go from 2 4 5. Now at 5 I cannot change the path, and I have to move on 8, and at 8 I can change the path, and I can go here 9. Okay, that's it. And both the array are not of the same size. It is not necessary. Okay, so basically I have to start from 0 and go to n. It can be anyone, right? End of the nums 1 or end of the nums 2. Okay, and yeah, score is the sum of the unique values in the valid path. And another question is that, can the are the elements repeated? That doesn't need to make sense, because if the numbers are repeated, I should just ignore it, right? So let's say if I have something like negative numbers. Are negative numbers possible? No, only positive numbers are there. So for nums I can say it is greater than 1 and less than, okay, 10 to the power 7. That's it. And talking about numbers repeated, okay, let's say I have two array, something like 1, then I have 2 and 2 repeated, and I have something like maybe 2. So it doesn't make any sense. If I go from 1 2 and 2, it seems like going from 1 2. So instead what I can do is that I can directly filter out nums 1 and nums 2 and remove these duplicate values. Okay, so redundant values are useless, can be filtered out, right? Okay, so now how we are going to approach this question, right? Now let's take an example, test case, right? Okay, let's take this test case. Okay, so I must know the beginning and ending, right? Okay, so one thing which I can do is that I can create, okay, let's see. So these are the two arrays. Okay, so let's say I start from 2 and I start from 4. I have two choices. So let's say I start from 2, then at 4 I'll start from 2. Now I'll check if the 2 is present or not, because 2 is already included in my path. So it's 2 included in the second sub array, so that I can switch. Either I'll have option to move forward or change the array. So can I change the array? I can change the array only when this number is present in the another array. Okay, which basically suggests me that how do I know if 2 is present? Either I can do a search, linear search, so that would allow me to do that. Okay, and talking about the constants, we have 10 to the power 5. Okay, one way is the brute force way, which is that I'll search all possible path. So which basically goes like this, is that I'll start Okay, so I'll have two options. I can either start from here, I can start from here, right? So I will keep two pointers, not two pointers, yeah. I will have one pointer. um okay, I'll have one pointer that basically tells me that I'm in which array. Okay, so let's denote this array with 0 and this array is 1. So I'll have one variable that will tell me I'm in which array, and I'll have one index variable in which index. So let's say I'll start from index 0 and I'm at 0. Now if I want to switch my array, I would have to know that if 2 is present here. Okay, that is not. Okay, so how do I know? I can create a map, something like index of, or something like index in nums 2. And similarly, if I am here, so I want if this 6 is present here, and if it is present, I want to know its index in nums1. So I can have something like index in nums1. Okay, okay, okay. So then I will start. Initially my index will be 0, and I can choose any one of these. So let's say I chose to start from the first one, so I will go 2 and I will search for 2. I'll look at the map and I will check if 2 is present in the map, which is index nums2. If it is not present, which basically suggests that I can't switch, so I will just move on and I'll have 4. That's it. Then I'll just search for 4. Can I switch or I should move on? So I'll have two options. I'll return the maximum of this. So I'll say for 4 I can switch. Yes, I can switch. And if I can't switch, then I'll just move on. So I'll return the maximum of this. So at max I will have to do n operations, but I'll have to return the maximum among this, right? So the iterate, so basically in the worst case I will have 2 operations, right? Okay, if I I think that there will be some sort of overlapping sub problems which can be optimized using memoization. And yeah, if I can first try to write a recursive approach, I guess we can optimize it. And yeah, so let's try it. So let's say I am here. I have max sum, okay, or max value. So what are the things I will need is that int index. I'll have int for denoting in which array I am. Let's call it flag, and I'll have vector both the arrays, which is nums1, vector of int, which is nums2. Okay, Okay, so okay, so I will be at this index. Okay, so I will be provided with initially starting index will be 0. Okay, so either I can stay okay at the same index, or switch. If I want to stay at the same index, I'll say int stay. Okay, so one more thing is that I have, since the answer can be large, so I have to return modulo result mod 1e7. Okay, 1e9 plus 7. So it would be better if I can just declare it here. Okay, yeah. So if I want to stay at the same index, I will say int stay, which will give me the maximum if I stay at the same index. That will be, I'll just call the maxval function recursively. Max value, if I'm staying at the same index, my index will be just increased, and my flag will be okay. I just want to switch the flag, right? I can just do a not operator and nums1 nums2 are static. Now if I don't want to stay, let's just switch. So 0. Okay, not stay, let's say. Yeah, switch path, because switch is a keyword, so let's call it switch path. So I can only switch if so what are the conditions for switching? I can only switch if okay, yeah, if this value, which is nums so let's have this, and val will do nums. Okay, it depends, right? So I have to check. Okay, so I don't know currently I am on which. Yeah, okay. So there it's an implementation problem. So firstly I want to know that in which okay, so I have to do something like so what I will do is that I will just okay, since I want to know which array it's I am currently on. So either I can do one thing is that I will check if flag equals to 0, which basically means that I am in the nums1, and write the condition for nums1. And similarly, if flag equals to 1, then I will write condition for the nums2. Instead of that, what I will do is that I will make sure that nums1 is the array which I am currently on. So I'll say flag equals to 0, or flag not equals to 0, which basically means that I am not in the nums1. So I will just call this function. I'll just make idx. I'll just make flag as 0. Okay, or instead of this, just make it simple. If it is 1, which basically means that I am in the second array, and I will replace nums1 with nums2 and nums1. Yeah, it should do the work, right? Now let's say I am in the second array, yeah, which basically means that I am in the first array. Yeah, that's it. But this would, make it difficult for me to apply DP, I guess. Okay, so let's firstly try to solve it using brute force, then we can optimize it. So I'll say that if int value val equals to nums sum. Okay, obviously, so this is my int value. Okay, now if I want to stay, I know that this is the maximum. If I want to switch, so I can only switch. Okay, so I have to, okay, let's say okay, so let's declare some variables. Map, I will have int. Let's call it what we did give a name, index in. Yeah, index in text. Nums2. Okay, yeah, but this would obviously change, right? So because we are just okay, yeah. So this won't work because we are fixing index nums1 nums2 here, right? So yeah, so okay, so let's complete it. So firstly, we'll check the condition for switching is that if index nums, I'm assuming, okay, so yeah, okay, let's assume if flag equals to 0, which basically means that I am in. So if flag, this basically assumes that I am in the nums1, right? If I am in the nums1, the value is, yeah. If I stay this, if I switch this, and if index nums, if I am in the nums1 array, I would like to check in the nums2 array if it is present or not, right? So I will check if index in, yeah, so I will count. Okay, so I will check if this value is present or not. If this is greater than 0, which means that it is present, then I can switch path. Switch path is equal to max value. I will say okay, so let's say I was here 4 and I checked on norms2, it is present. Okay, now I will, so my index would be obviously changed. Okay, so that would be index in norms2 value. I will just find in new index. Okay, that's it. Well, so I will get a new index which is 0 here in this case. Okay, and there is one issue, is that again if recursively call, now again it will check. So this will have infinite recursion, right? So I will just make it move one step forward. So I'll say okay, index in whatever the value, new index. I'll just increase it by 1, so it will be new index. Okay, now I just switched it. Okay, if I am staying, then I will not change the flag. Okay, now norms1 and norms2 stays the same. Okay, now I'll say return max of it will be stay and switch path, right? And if this is not the condition, then obviously again it is pretty much same. Just in this case my norms1 will be replaced with norms2. Okay, my bad, here norms1 and norms2 remain same. And switch path, yeah. Okay, so I have to add one more thing, which is current value, right? Yeah. So this is the brute force approach. And instead of norms1, I'll just wait. I'll just change it to norms1. Okay, that is pretty much correct, I guess. And now I will just initialize the map. I will say okay, for int I equals 0, I less than n I plus plus, and I will have int n. Okay, let's just do norms1 dot size. I'll just say hmp, or I can say what is it, index in norms1 norms1 I, this is the value, equals to whatever its index is. And similarly I will initialize another map. Initializing map 1, I call index map 1, and similarly index map 2. So I'll say okay, That's it pretty much. Now once the initialization is done, I will just call this function with the return, which is maxwell. So maxwell. So I have two sources initially also, right? I can either start from okay, so I'll say I can choose two options. I will starting with index 0. I can start with flag 0 or flag 1, then nums 1 and nums 2. So int max start 1, that will be this. Okay, and I will just return max start 1, max start 2. Yeah, and one more is that the condition is missing. What if, when should it return? So if I say that if index okay, my bad. So if flag equals 0, then I'll say if index is greater than nums1 dot size, then return 0. Similarly, if index is greater than nums2 dot size, return 0. Greater than equal to, right? Yeah. So this should pretty much work. I know the code is little bit complicated. Okay. Yeah. Nums2. Will it give me correct result? Yeah, it is giving me correct result, but obviously it is not efficient, right? Because the time complexity is not under order of n log n. Okay, so how can we optimize it? And there one more thing we haven't taken care of this thing, which is returning. Okay, so what we can memoize here? Okay, so let's see. Okay, so let's try to understand. Okay, so let's say we are at some point here. Okay, let's see here. Okay, and now we want the maximum, that I am in this index and I am in this array. So the thing is that I will be at index 3 and my flag will be 0, so I want the maximum for this. Okay, I can reach this at many different scenarios, right? Either I can reach it by going here, or there can be a situation that I start from here, then I went here, then I again reach this state. So which basically means that there are redundant states, right? So which can be optimized. Optimization can be done using memoization. So we can optimize it using memoization. So the states are basically index and the flag. So what I will do is that I will basically create one vector of int, let's call it dp, and we'll just resize. We'll say dp dot resize. I'll say the size will be okay, so what is the maximum index I can be of, right? So let's say it will be 2 and vector of I'll say int, and what is the maximum size it will have? It's it will be max of, okay, so and the max length will be max of nums1 dot size, nums2 dot size, right? So I will just have this here, it will be max length. So yeah, okay, this is correct way of initialization, right? I'm declaring a vector of 2 size where each 2D vector, and we have for each one of them and I will initialize it with -1, so that would work. And I'll just say if dp of flag is flag and I have index does not equal to -1, return dp of flag idx. This is the line. I'll just say dp of flag and idx, that will be equal to this. Similarly, I will just copy paste the line here, and similarly I will write dp of flag and idx will be this, right? And another thing is that I'll have to take care of that thing which is the modulo 1. So I'll say I'll just convert it to long, and I'll just take mod of u, mod of this return value, similarly again mod, right? Since these two lines are same, I will just repeat it. I know there is a redundancy, I have to find some way, of removing this redundant code and do it with only one thing, one basically statement. So let's check if it is working. Okay, it's returned. Okay, yeah, that it is not here. Just to make sure that overflow doesn't happens. Okay, yeah, so since it is being used, I should declare it here. Okay, so the time complexity would be order of n. Okay, any edge case that we can think of is that obviously our repetition case, that won't work here, right? If we try to run here something like 2 2. Okay, that is not allowed, so which means that we don't need to take care of it. I guess it should pretty much work. Let's try to submit it. Okay, wrong answer here. Okay, we passed almost 76 test cases. Let's use this test case. Why I'm failing, I don't know. Yeah, it shouldn't be an issue. Okay. Obviously, we have maximum length here. We have DP length here, maximum length. Just for the safety. And we have initializing index nums1 and index nums2, which basically stores the occurrence of the indexes. And we have max start 1 starting with 0 index from index 0. So yeah, it should work, right? What is the issue here? Because we are exploring all possible states, right? I am starting at 2. Now I can also start at 4. Okay, so there is some issue with staying at the same index. Okay, if I want to stay at the same index, which basically means that okay, I will stay. I will increase my index, right? And if index is greater than nums1 dot size, then I'll return nothing because it is exceeding. Okay, I don't know what is the issue here. Is it 1 is 7? It's 1 is 9 plus 7, right? Okay, let's suppose I was at 2. I went to 4. Now I can either switch path or move on. Let's say switch path 4. Okay, so I was at 2. Then I call this switch path function, switch path um, statement here. So now my max value, now my new index, whatever was in the nums 2 value, the index is 0. Okay, changing the flag. It's like I was set flag 0. This is not working. Looks like some overflow issue. Still the issue persists. What is the issue? Stay versus switch path. So I am at index 2. If I stay, flag will remain same. Norms 1, norms 2. If I switch, max value, new index. This is pretty much fine, right? What is the issue here? Okay, let's see if there is issue with overwriting or something. Let's run this only. Wrong answer is there. What is the range? Range is 10 to the power 7. Okay, 10 to the power 9 is the range. Okay. One, two, three, four, five, 6, 7, 8, 9. Just to confirm, let's see, max size of C++. Power of 10 is to the power of 9, right? I hope so. is 10 to the power 9. So I should make it long. Just let me print out. Okay, cout mod handle. I just want to return. I just want to check. It's working. Just for safety, I'll just try to test long. Does it work now? Okay. Still the issue persists. I don't know what is the issue. I tried my best, but guys, I still can't figure out the solution. Everything is fine. I don't know why the result is not working. It should be working fine, right? It should be working fine. Okay, if index is greater than nums1 dot size, then I will return if dp, which means that if value equals to num I, stay at the same index, right? Okay, so I'll stay at the same index. And I can only switch path or I can only switch path if it is greater than 0, and I decided to switch path, so the expected is I'll have to return 0. Okay, I want to stay on the same path. I'll say index plus 1 flag switch path if index nums1. I want to flag is 1, right? Just simplifying it, I don't know. The index path, index always keeps increasing. It's like I go from 4. Okay, so for 4 I can't go back, right? For 4 I'll just move to 6. For 6 I can check. +1, I have to move forward. I know it is working fine. Okay, let's try to uh, ask GPT what is the problem here. Find the bug. It's bug, sorry. Okay, this is the question. This is the question. Find the bug. Okay, I don't know what is the bug here because the solution looks pretty much good to me. And yeah, because I'm exploring all the path and I'm just memoizing it. Okay, the code uses a two-dimensional DP. Since the problem has a result return long it's unnecessary, you can change. Okay, does not handle the case when both are empty. Okay, it is not possible. Obviously, let's say this test case is failing. Too long. The solution is fine, right? Let's see if ChatGPT can make it shorter. Make this code shorter and precise yet readable. The solution looks fine to me. It's going to win an hour and it's not good, right? I came up with a solution, but the implementation has some issue. Obviously, maybe let's try to shorten it. Okay, since we need to check, we need to switch. Okay, since most of the things are common. Okay, it depends on flag, right? Can I do it without using a flag? But I need to know that in which area I am, right? That is an issue. If index is greater than nums.size, return 0. I'm changing the path flag here, right? New index. I don't know. I'm pretty much tired. Okay, guys. I still cannot find the solution. Uh, I'll just pause it. Can I hide the timer? I cannot pause the timer, right? I'll be back after a short break. So guys, it was meant to be a short break, but yeah, it took me around 20 minutes. Okay, so I guess I can't find a problem with this. I don't know. Okay, so here is a simplified version. Obviously, this is wrong if one is smaller, and it returns 0. Yeah, this is wrong, I guess. Yeah, so this is the solution. I don't know why it is wrong. Ah, okay, so I can start either from 2 or yeah. Okay, so there is anything that I'm missing. Okay, so if I want to stay, I will say index plus 1. Okay, I want to stay. I'll just okay. So if I want to stay the same, I will increase the index to index plus 1. Just right. Okay, flag will remain same. Nums1, nums2. I don't know. Yeah, it should be working, right? Something missing. I don't know what is the issue here. Okay, let's check on to solutions. I don't know. Wow. I don't want this one. It's okay. So dynamic programming solution, but without. Okay, I can use. Okay, instead of using map, I can use sorting. So nlog, and I can go with nlog and solution. This is pretty much a good solution, but I want memoization. I don't know, yeah. I can either have 458 or 468. Okay. This code is good, but I don't know what is the issue here. Is it with the map? Is it with the map? Uh, is it with the map? Another map, int. I have 76 test cases passed, 75, 76 is wrong. Nums 1 is this and nums 2. Right, 3, 2. It's less. Why is it logically wrong? Isn't logically wrong, right? Because I have a DP and okay, so what is the size? See out max length handle. Okay, 5600 is the size. Initializing, we have index nums 1, index nums 2, start. Okay, let's see out max start 1 handle. And if I say see out max start to handle, so if it's not getting us the desired result, then I'll have to solve it. Okay, it's giving me the same answer, which it's not possible, right? Because 5. Since I'm at 5, I can choose to I can go with 5 5. I don't know, yeah. Like I want to know this size of both. Yo, I just can't figure out. Yeah, like some both have different sizes. I don't know. Reset test cases. Let's have one test case. Okay, which is I'll just make it 10. Just make it 6. 6 once it's 15, so it works. And I'll just have a test case like I can go from 3 like from 2 3. So 2 3, I'll go to 4, so it will be giving correct results. It's working fine. I don't know what is the issue then. Okay, so how does they implement it? Okay, let's see. I don't know. With memoization, I don't know. So I'll say uh, dp mod equal to mod. Same thing here. So still it runs same. Is issue with my there is issue with my submission with my logic. Is this an issue? So I can have 6 here. grab test case like can I don't know, man. Signing off, guys. I will just try to find the solution, then I'll be back.